Hi, everyone. Welcome. We're so excited to have you here. This is the Invincible Workload Management with MongoDB Atlas tutorial. The session is part of our Explore the MongoDB Application Data Platform track. Today, we have Shamik with us. Shamik is a product manager at MongoDB based out of New York. He works on the service architecture team, building out new features that make the MongoDB server more resilient and resource efficient. He enjoys learning hip hop, dance, brewing coffee, and playing Smash Bros with friends in his free time. Today, Shamik is going to be doing a deep dive into the wide spectrum of faulty scenarios that can happen in production, as well as effective workload management techniques in MongoDB Atlas to cover them. You'll notice that this session goes until 1:15. We're going to try to get you guys out of here before 1 so we can make it to lunch. Another thing is that on the app, we also have an option to rate this workshop when it's over, so please just go and play around in there. That'd be super helpful for us. Okay. Now let's give a round of applause to Shamik.
Thank you, Chris, and everyone. Welcome to MongoDB World Day 1. Welcome to New York. This is one of my favorite parts of working here at MongoDB, speaking with developers across the world about how they use MongoDB and learning about the different kind of experiences that they're building for their users. And so really, it's an honor for me to have you here today. I am a product manager here at MongoDB. I focus on understanding the different pain points that customers are having with MongoDB and understanding what our teams can build to innovate and solve the problems that they're experiencing. Lately, I've been focused on working with different engineering teams to build solutions that make MongoDB more scalable, more resilient, more performant at high workloads. And I've had the chance to work with a number of our largest customers to learn about the best practices that they've had, to hear about the different techniques that they've used that have led them to succeed with MongoDB in production. And I figured that a lot of their techniques might not be so well known in the broader developer community. And so I put together this talk. It's called Invincible Workload Management with MongoDB Atlas. I hope by the end of it, you will understand different techniques to have your database be ready for anything that can happen in production, understand what kind of metrics are important for your workload, as well as really understand how to leverage the cloud for making sure that your application is highly available and ready to meet your end users' needs. We'll be talking about the anatomy of a database production issue. We'll be talking about how you can make changes in your actual application code for greater resilience. We'll go over how to leverage Atlas, our fully managed database as a service product, to help you prepare for these overload scenarios. And then last but not least, we'll go over some of the upcoming resilience improvements, just so that you know that we are a company constantly focused on innovation and focused on helping customers meet new scale. So that being said, I think that the biggest motto that I've taken since working at MongoDB, or I guess since being in the tech industry in general, is that we should assume that anything that can go wrong at some point will go wrong. We need to have that ingrained into our mindset. We cannot just simply have something built and succeed in test, something that works in production for some time, and assume that because it works once, it'll forever work. We should assume that anything that we do, we have some control over it, but outside of that, we need to prepare for all the things that are uncontrollable. There are things like uncontrollable networking issues, right? We all are using some sort of private networks or public networks, and we trust our providers to give us 99.99% availability, but there are, of course, chances where something goes wrong with the underlying cloud provider, and for some momentary time, uncontrollable networking happens, and that manifests in some problems for our customers. If you're building an app that has multiple layers to it, you're leveraging microservice technologies to have services that do very isolated but very powerful responsibilities. But if you're layering that such that if one part of it breaks, then maybe the bottom layers are now getting a much higher overload, that can lead to failure of the services downstream. And so we need to prepare for the events where upstream events are no longer working. I know that this is the most common scenario where teams are constantly building new queries, they're powering new use cases. But something that happens is that they test a query and it's fine, or maybe they're following some practice they think is right, but once it goes into production, they find that it's actually not as optimal. And that new highly inefficient query can have devastating impacts for their end users. And last but not least, I think this is one of the things that I call a good problem to have, where your application is meeting its record volume of users using it at one time. Maybe you've just launched a new feature or announced a new capability, and everyone is eager to get their hands on it. And what that manifests is that it's going to lead to your record number of operations per second. All of these events that we have described over here are scenarios that I think that the best teams, the best production companies are constantly keeping an eye of. But unfortunately, it seems that in today's world, these are a lot harder to really handle than they should be. And so in this talk, we'll go over the techniques that you can use Atlas, MongoDB, to be resilient to these scenarios. I think the first question I always ask a customer is, hey, like, how are you preparing for an unexpected event, one of these things? And the answer I often get is, oh, well, we provision our servers to be double the amount that we need. Or maybe we've provisioned our servers to be 30% more than our steady state. And unfortunately, what I'm realizing is that over-provisioning isn't truly a solution to workload management. The truth of the reality is that resources are infinite. The amount of disk, CPU, RAM, they all have limits. And when you pay a service to use some resources, you're not asking for an infinite amount. You're paying for a very finite amount. And so eventually, whatever workload you have, it will hit this limit. And it's better that we're prepared so that our database takes the right actions so that we never have to hit that amount. Because when we hit a limit, when we hit that resource end, behavior becomes unpredictable. And we want to avoid that as much as we can. Resources are expensive. I think in today's world, even though the cost of storage has astronomically decreased over the past decade or two, it's still very expensive to provision very, very large servers. And for many of the businesses that I work with, unfortunately, cost is not a thing that is such a lightweight topic. It's important that we're able to innovate, but innovate at a pace that's scalable and financially feasible. And so when I hear about over-provisioning as a technique for workload management, I hear that as a very temporary solution and not one that often lasts the test of time. And last but not least, if you have a bigger machine, that does not make the actual operations going into that machine more performant. If you're doing something that's really, really inefficient, more resources does not speed it up. Kind of like if you have a car and you have really, really fast tires or really, really efficient tires, if the underlying engine is still not a very good one, that car will not be a very fast one. And so it's not, in today's world, we can't just add more resources and then expect that to speed up the performance of our operations. And so all this is about avoiding this scenario. We want to avoid database production issues. Scenarios where our nodes are no longer able to communicate with one another, where our applications are not able to succeed, or we're getting influx of errors. And the most important thing is that we want to do these things to avoid any impact to our end customer. So I want to go through quickly the anatomy of this scenario that I'm talking about, because this is going to be the thing that we're trying to avoid via the techniques going through the rest of this presentation. So let's assume that we're running an architecture where we have multiple numbers of clients connecting to some service. Let's not even call that a database service at this point. The architecture style that I see often is that this service is being shared by multiple different development teams. Maybe they're powering different parts of an application. Maybe they're sharing some data. And so the number of clients connecting often tends to be much higher than the number of nodes that are actually servicing those clients. Right, we begin sending a stream of requests to the service. Everything is fine. The service begins executing those requests. And right, the nature of when we execute requests, they're consuming some resources until they complete. They're taking up threads, connections. They're using CPU for actual execution, disk, storage. And the unfortunate thing is when the operations that we're sending to the database are really, really highly inefficient, as an example of a production issue that can happen. In this scenario, the service that we're running reaches close to its resource consumption limit. And maybe nothing has gotten too bad yet, right? We're still at the maybe 80% mark for across the resource line. But it's really once we continue the execution of the current requests, the new influx of requests coming in, right? Because your end users don't stop using your app just because other customers are having some slow requests. And ultimately, all this manifests into an unbearable experience for customers where their operations are timing out, they're not able to succeed with loading whatever page your app has. And the nature of why all this is happening is because we are not following best practices with how we run clusters in production. And so in this presentation, we'll go over 2 different techniques for how you can avoid the scenario that I mentioned here. The first one will be how you can architect for resilience within your application. Right, this is actually making changes to your application code, and this is really agnostic of any underlying cloud deployment strategy. And the high-level strategy here is that we want to prevent the likelihood of failure by bounding resource consumption, isolating workloads where possible, and handling the phenomenon of errors if they do happen. But first and foremost, let's take a minute to quickly go over what are the things we're trying to bound. Every time we have a request come into some service, that request, as I mentioned, takes up some resources. And the hardware resources that we're going to be doing at all times are compute, memory, and disk. In the MongoDB context, your CPU is going to be responsible for the actual execution and processing and communication between the different other components of your computer. More generally, it's responsible for query execution, and it's scaled by the number of cores that your machine has. So oftentimes, if you look at metrics, you'll see the CPU utilization normalized by the number of cores. So you'll see a kind of true metric of like how often how much of time CPU is being used. Memory is really one of the core places that are important for anyone managing a database. This is where we're going to be ephemerally storing data, and we hopefully want our requests to be making use of data in memory as much as possible, because requests to memory are much, much faster than the alternative, which is requests going to disk. In the MongoDB context, we use about 50% of your provisioned memory to run Wired Tiger, which is our storage engine. We enabled it by default, I believe, about 7 or 8 years ago. And the idea is that most of that memory is being used to manage the Wired Tiger cache, which is basically holding a set of your data in cache so that you don't have to go into your disk. Optimally, we want to make the working set of your data fit into this cache so that basically 100% of your operations at all times are avoiding disk. But that's the thing that we'll talk about later in this presentation. We also are using memory for things like connections, buffers, memory to do in-place things like sorts. And so for the rest of this talk, we'll be thinking about how we can maximize our usage of memory in an efficient way. Last but not least, we have disk, right? This is the actual more permanent form, more persistent form of storage of your data. We compress it by default using Snappy. And this really represents the total size of the data in your collections. And the common metric that is often used in the disk context is IOPS, right? Input or outputs, requests sent to the disk at any time. And we call that we look at that from the context of read and write requests per second. Most of you are probably familiar with the hardware, because I'm sure all of you have at some point used other services where you've had to manage the optimization of these hard resources. But the other thing is that MongoDB itself has a layer of resource management that I think is very critical for all of us to understand, especially in the context of making our operations use resources very effectively. The first and foremost is the notion of database connections. This is how MongoDB, your driver, will connect to one of the nodes in MongoDB. It'll authenticate itself, it'll complete a handshake, and then after that, that connection can be used to actually service MongoDB operations. A key thing to know about database connections is that each of your application clients will maintain a connection pool, a cache of these connections at any point, and that's bound by the minimum pool size and the maximum pool size. As you can see here, like that, the connection pool will scale up and down based on the workload that your application is seeing. So if your application is getting a lot of connections, a lot of operations, the number of connections will scale up. Each connection is capable of servicing one operation at any time. And you can assume that each connection takes up about 1 megabyte of memory. So you can see how we want to be intelligent with the way we use connections. And that's really managing concurrency going into the database. We also have storage engine tickets, which manage the concurrency of operations happening at the storage engine layer. As I mentioned, the storage engine is basically the mechanism that manages the storing of data in memory and in disk. But in MongoDB, we actually maintain concurrency of those operations via a notion called read and write tickets. And by default, Atlas clusters will have 128 read and write tickets, 128 read tickets, and 128 write tickets. so that at any given time, 256 operations can make concurrent changes to the storage engine at any time. And it's really, this is really important to understand because we can throw in 100,000 operations to our database, but at any time, only 256 operations can be executing at the storage engine. So now going into the different techniques, we'll be going over 9 total. And the first one is my favorite. The idea that you really want to be intentional about bounding your consumption of operations. MongoDB has a feature called maxTimeMS, which states that after a certain amount of milliseconds have passed, MongoDB will now terminate this operation because we, for whatever reason, believe that this is no longer a useful query. Maybe you want to use this to correlate the expectation that your end users have with MongoDB. Maybe that for you, like if an end request goes beyond a certain time, it's not even worth having. But the way that I like to use this is basically by preventing the likelihood of any new query potentially being unbound for whatever reason. We want to avoid the case where we have a new query, it's not indexed, and that is now scanning every single document in our collection. It's just going on forever and ever, because that's really how we get into that unbounded memory problem where we're going in and we're just taking up all the resources as we can. The big thing to note here is that if you're applying this on an operation basis, you're basically saying that it's not going to happen on an individual operation, but every instance of that operation, right? You have a login page, and every time a customer logs in now, all those concurrent login requests will now be bound by this maxTimeMS field, which states that, hey, now I'm preventing the likelihood of overconsumption because after a certain point, I'm just going to end the query. But the key thing about using maxTimeMS is that now, in favor of you not having resources being overconsumed, you'll be getting an error in your application. And so it's critical that all of our applications by default have error handling built into them. Because for whatever reason, if your app gets an error, that can lead to unpredictability for your app. Some applications might close, some might have to re-authenticate. I've seen a wide spectrum of behaviors, and when applications restart, that leads to all those connections that I mentioned earlier being restarted to match the min pool size, and really that creates an unpredictable experience for your customers. The flow here is that if you have an operation that fails, MongoDB, if that operation is retriable, will retry that operation once. This is good because it lets you get over the kind of like persistent error phase where like, hey, I got an error because there was a really small amount of overconsumption or a really small network event. And that retry will happen once. And that seems to be the way that most customers avoid errors. But unfortunately, for really high workload scenarios and events where something unpredictable happens, that error might persist and that retry might fail and the error will go back to the application. But if our application has error handling built in, then we avoid that, we catch it, we have some logic behind it, we might log it, we might alert someone with it. But error handling to avoid application failure is a necessity if you want to run a mission-critical app that's acceptable for your end users. The next topic that I want to talk about is write concern majority. This is the setting in MongoDB that states the level of acknowledgement your write operations must have before they're considered a success. In MongoDB, we run highly available clusters by default. If you use Atlas, all your clusters will be deployed as a replica set where you have a primary node receiving all your writes, and those writes are asynchronously replicated to the other nodes. And the idea behind this is that if one of the nodes goes down, we want to make sure that one of the secondaries can step up and become that new primary to service your writes. And the different settings that write concern can take are basically how many nodes you want to have this level of acknowledgement. The more nodes you have, the more durable your writes become. Because we're saying that, hey, more nodes have approved that this write has succeeded. And we're saying that that prevents the likelihood of all of those nodes going down and our data getting rolled back. But the second benefit that I've learned about from write concern majority is that it really strengthens your stability because it causes your application operations to be responsive to the state of the database. Let's go over what I mean. So let's say we have an application, it sends a write operation with write concern majority. It goes to the primary node, and the primary node performs that write. That write succeeded, and now the secondaries are asynchronously applying that write. Let's say the cluster is really, really busy, and so it takes the secondaries a decent amount of time to perform that write. Well, what's going to happen now is that the connection for performing that write from the application is actually still being held because that write operation has not yet succeeded. it's being responsive to the state of the database cluster and only completing once we have enough resources to fulfill the full write operation. The benefit of this is that now, instead of write operations just being thrown right at the cluster is already saturated. Those operations are going to wait at the application layer. They're going to wait for enough threads and enough connections to be available in the connection pool to continue serving those operations. And the benefit here is that we're avoiding excessive resource consumption because we're having our operations respond to the state of the database. The good news is that write concern majority is now the default since MongoDB 5.0. But if you're running MongoDB self-managed, or maybe you've made the change of this default write concern, I really recommend you considering if stability is important for your application, and if so, opting in for write concern majority. The key thing, I think, the key concept that many of us have probably heard about is workload isolation. I know Sahir talked about it a bit in his keynote today, where we want to isolate our operations away from each other as much as we can. We have some operations that are servicing real-time application use cases. We have some operations fulfilling more analytical use cases. And the nature is that maybe the real-time use cases are potentially a bit more important and a bit more mission critical for our application, whereas the analytical use cases are a bit more, hey, it's okay if they take a little bit longer. It's okay if we take some more time with them. The challenge that I've seen with customers not isolating their workloads is that if they have an influx of these analytical operations that are very resource intensive, these aggregations, what they'll experience is a competition between resources between the real-time operations and the analytical operations. But the good news is that you can leverage analytical nodes in MongoDB to isolate your workloads. Here, you can have a node that's specifically designated for these analytical operations, which you'll tag in the actual read preference of that operation. They'll only go to analytical nodes, and then you can have the rest of your cluster being used for your actual application workload. The benefit there is that you'll never have the scenario where you have analytical operations competing for resources with normal read and write operations. And that's really the best way that we can avoid the competition of resources. The good news is that on Atlas, we have now delivered a new feature, or rather, a new feature will come out very soon, that analytical nodes can now have a different instance tier than the rest of the cluster. Here you can see that our general replica set is running at M30, but we want more hardware. We want more CPU, more disk, more IOPS for these analytical nodes because they're very resource intensive. Well, now we can actually scale those independently from the rest of our cluster. And this is coming out very soon, and I hope you all will take advantage of this new feature. And last but not least, I think the easiest thing that anyone can do today to get their hands on more resiliency is upgrading to the latest version of MongoDB. Every day, the product team at MongoDB tries to understand where are our customers experiencing limitations today, where are they running short, and we make each version of the database more resilient than the former. Just some examples of resiliency features that we built in the past 3 releases. One of them was we introduced flow control in 4.2. This is the idea that we want to build resiliency to the scenario where we have an influx of write operations, and it takes our secondary nodes some time to really catch up to those write operations to the point where sometimes they can become overwhelmed. Well, now with flow control, what we'll do is we'll be managing the flow of those write operations to the point where we'll be throttling those writes on the primary until secondary nodes are no longer overwhelmed, and then continuing the execution of those writes. This is really making the trade-off of a little bit of additional latency, but we're avoiding the state where our database has now gone unavailable. In 4.4, we introduced hedge reads, which is the whole idea that you have a read operation. It's able to go into any number of those secondaries in MongoDB. What MongoDB will do is that it'll send reads to multiple nodes, and whichever node responds faster will be the one used to service the operation. And that's really good because it's helpful to minimize the likelihood of these unexpected events happening in production that cause P95 and P99 spikes. So if you're someone that has really high standards for your P95 and P99 latency, I recommend upgrading to at least 4.4 to leverage hedge reads. And then in 4.4, we made initial sync, which is the process of getting a new node caught up to speed the rest of the cluster much faster. We've heard that initial sync can take a long time, and unfortunately, sometimes events can happen that cause the initial sync to crash or become unsuccessful. But in 4.4, we released resumable initial sync, which enables your cluster to, if one of these events happen, to resume that sync as nothing happened when the cluster is healthy again. So these are some really cool features. I hope you'll take advantage of them. But that's it for what we can do in the database land. If any of you have used Atlas, you'll know that MongoDB Atlas is a fully managed database as a service where we give you a connection string and we manage all of the infrastructure and provisioning and maintenance and upgrading of your database cluster so that your teams can focus on innovation and development while we focus on the actual administration of your hardware. But the thing is, since the last 6 years, resiliency and high availability have been top of mind for the Atlas product team, and we built a number of features to help your database just be the best against overload. And when using Atlas, our strategy here is that we want to have a timely reaction to any form of overload by taking advantage of cluster metrics. We'll be doing this by taking not only an automated reaction to cluster metrics, but also taking a human reaction as well. By us managing your servers for you, what happens is that we're able to track key metrics about hardware and database, and we're able to monitor this over a very long period of time with a very high level of granularity, always making improvements. But the whole idea behind this is that we're managing your cluster. Instead of you using complicated tools in the OS level to see what's happening at your operating system, at your database, where we're actually giving you visualizations of what's happening in the database land, in the hardware land. All of the metrics that I mentioned at the start of the presentation, you can see very easily on Atlas. And so the first feature that I've seen customers really succeed with in making sure that their cluster has enough resources is taking advantage of Atlas autoscaling. The whole idea that Atlas will automatically scale your clusters up, working with the underlying cloud providers to scale up your storage, to scale up your instance tier, to make sure that your cluster has enough resources as needed. And the algorithm that we use is that if your CPU or RAM has seen sustained utilization of at least 70% over the past hour, we will then scale your cluster up to the next tier. As you can see, from going from an M30 to M40, we're doubling the amount of RAM, doubling the amount of storage, and doubling the amount of virtual CPUs that the cluster can experience. And this is really great because if you're someone whose cluster is really starting to see an elevation in workload, you don't want to be the one managing the scale up yourself. Let Atlas do that for you. We'll monitor the metrics, and this is how you can provision your cluster to have enough resources. There are some considerations to have with autoscaling, and nearly all of them are due to the fact that autoscaling is not an instantaneous thing. If you're using storage scaling up to a greater storage capacity requires a sufficient amount of time for us to work with the underlying cloud providers to actually prepare and copy data to move to the new disks. And so if you're trying to provision for maybe burst write workloads where you want storage capacity to scale up, I don't think autoscaling is the best fit for that. Autoscaling is a better fit for more sustained utilization scaling. If for you, being constantly scaled up is not an option, you can also use autoscaling to intelligently scale your cluster down. What we'll do is we'll monitor your cluster for 24 hours, and if the same resources that I mentioned, CPU and RAM, go below 50%, we'll scale your cluster down as the same way that we would scale it up. As I mentioned, bulk write activity is really not a good use case for Atlas autoscaling because the high speed write activity, creating a lot of activity in disk, creating a lot of new storage or a really high amount of IOPS, really not the best fit for something like autoscaling. And then finally, you can right now only scale one instance tier at a time. We cannot skip from, let's say, like an M30 to an M400. We'll scale from M30 to M40 to M50, really making sure that we're only adding resources if we need to. We don't want to overscale unnecessarily. And that's how Atlas can use metrics to scale your cluster up. But Atlas can also use metrics to send you timely alerts so that you are fully aware of when your database at any point has hit these scary limits. You can use Atlas alerts to send alerts to anyone in your team, database managers, SREs, engineering directors, on a whole spectrum of different activity happening in your database. If your CPU or RAM or disk has hit some limit and you want to know specifically when it hits 55%, you can use Atlas alerts to send you that number. If you want to know when the amount of concurrency has reached a really high amount, when there's really not many resources left, you can use Atlas alerts for that. If there's index suggestions, you can use Atlas alerts to let you know that, hey, there's an opportunity for you to improve your schema, improve your indexing strategy. And this is really important because, unfortunately, I think whenever I see an escalation or a case where some production issue happened, the issue the underlying reasons were really trivial sometimes. We're like, hey, like this query was really inefficient, we're missing an index. But these issues can almost always be avoided if the right team, the right person, reacts in time, becomes aware of the issue, we page the right people, and they're able to implement the fix with the right context. So some metrics that I recommend putting some metrics on, right? We of course always want to be on top of our application workload, knowing the rate of our queries, our commands, our execution times. We also really want to know if we're hitting resource utilization limits. So keeping an eye on disk usage, CPU utilization. A big behavior that I've learned is that basically anytime things are getting slow, not only will resource utilization be getting high, but we'll be seeing this behavior of queuing where maybe this operation in its lifecycle has succeeded in one part of MongoDB, but now it's waiting to get resources from another part. And so monitoring the depth of your disk queues and knowing what the max disk queue depth is, that's a really critical way for you to understand that, okay, hey, I probably hit a limit now. Replication is, as I mentioned, the way by which MongoDB delivers high availability. And you want to make sure that you're aware if replication is able to succeed. So you should look at metrics like the op block window, which basically states what's the maximum limit for which the primary can be ahead of the secondary. What is the replication lag, which is another word for the current lag between the primary and the secondary. The headroom, which is basically how much we want to enable between the primary and the secondary, and the generation of how much the op log is getting. And lastly, we have the storage engine, which I mentioned is responsible for the management of data in MongoDB. We always want to keep an eye on for if we're running out of read and write tickets, because that's a sign that we are now hitting either some high workload or some really inefficient workload. And this is the list of metrics that I recommend setting an alert on. I think the best way that you can understand what the numbers are really dependent on your application. So really recommend sitting down with your team, taking a look at these metrics, and figuring out that, hey, at what number do we want to be aware, and at what number do we want to start, I guess, freaking out? The cool thing about Atlas alerts is that it's very, very highly configurable. You can set alerts on specific hosts, at the replica set level, at the cluster level. You can use it for individual developer data platform products like Realm and Serverless. And you have a lot of control over like, hey, I want to know if this number was being met for this many minutes, and then send it to this person over this method. We do this because we want to make sure that you can get this information in the manner that best suits you. And we're constantly working on new integrations. We have integrations with Microsoft Teams, Prometheus, Datadog, New Relic. However you monitor your data, you can work with MongoDB Atlas to get the information you need as soon as possible. Really quickly, I know we're getting close to time. The key thing about Atlas metrics is understanding how your database creates traffic, what those patterns are, and taking the right actions based on those metrics. We don't want to be scaling up the wrong resources, because if we're contending on IOPS, adding more CPU or adding more RAM will not solve the problem. If we know that our workloads are really quiet on the weekends or at like 2 a.m., it's at that point when we want to do things like batch jobs, index builds. We want to understand when our low activity periods are and save those high activity operations for those times. And the good thing is that Atlas Metrics gives you all the information you need to get those insights. If there's anything that I want you to leave from this presentation, is that I've learned that inefficient operations are almost always the root of most production problems. And the scenario that I've seen is that there's a new query that's being launched. It's in production, but maybe the volume isn't so high. The queries are inefficient, resource utilization isn't super alarming, and so inefficiency is unnoticed. But it's when the workload actually scales up, right? We have some event that leads to a lot of operations, that inefficiency becomes amplified. The resource consumption per query scales up non-linearly, and for your customers, that leads to latency spikes. So really, if you can do anything, keep an eye out for the efficiency of your operations. The most common examples of highly inefficient operations that I have seen in my time here are places where we're not having indexes when we need them, right? Because instead of maybe scanning one document, we're now scanning the entire collection. That is catastrophic. Places where we're doing sorts unintelligently, right? In-memory sorts, sorts where there's blocking stages, that's just gonna take up basically all of our memory. Dollar lookup using unintentionally, right? Dollar lookup is the ability for you to essentially do a SQL join across multiple collections, but if your schema design is suboptimal, that can lead to lookup across many collections, which is a really inefficient query. And things like case-insensitive regex and expensive query expressions where our schema design is suboptimal. So when you go home, really keep an eye out for, hey, all these scenarios, am I using them optimally? Because maybe if they're not problems now, if they are inefficient, they may manifest into a problem down the line. And if you don't want to spend the time understanding all those things, the good news is that we have a feature in Atlas called Performance Advisor, where we monitor your slow queries and analyze them, and give you recommendations for what indexes we think will be fruitful for your application. We'll give you recommendations on which indexes to create, which ones to drop, maybe they're not being used or they're just causing more harm than good, and we'll also give you recommendations in your schema. So all of the problems that I mentioned here, that's the #1 job of this feature right here, and so really leverage Performance Advisor to keep an eye out for suboptimal queries. Here you can take a look at the quick recap if you just want to quickly understand that we can make improvements at the application phase and by using Atlas features. maxTimeMS, error handling, reconcile majority, using the latest version of MongoDB, and all of those features that I mentioned about Atlas, these are all designed to minimize work for you so that you can use these features and you don't have problems manifesting for customers in production. Last but not least, as I mentioned, I am constantly trying to learn from customers about their experience with MongoDB. And the key improvements that we have coming on the way are in the land of observability, giving you more granular and actionable breakdowns about how resources are being used, giving you recommendations on new times to scale, right, and improved scaling experience during overload. We will be making enhancements to how we schedule operations in MongoDB. And finally, we'll be giving you even more detailed metrics about what the database is doing during overload, so that you have all the right information you need and MongoDB does the right things during these scenarios that we call overload. And we are now nearing the end. If this is a topic that you found interesting, I recommend going to the talk called 12 Patterns for Extreme MongoDB Performance and Scalability. The speakers of this talk are some really incredible folks. They've been in the database game for a long time, know a lot more about this than I do, and I really recommend learning from them. This is happening on day 3. If you haven't used Atlas, I really recommend just spinning up an Atlas cluster, seeing what it's like, and thinking about if for you managing against workload specs is important, see how Atlas can fit into that narrative for your application. And then lastly, please leave me some feedback on this talk. I'd love to hear about how I can do better next time and if the information you all saw was useful. But anyways, everyone, thank you for coming to my talk, and I hope you enjoy the rest of the world.